Pythagorean Theorem Assessment Review. Number 1, label the sides of the triangle with A, B, C, and label which side is the hypotenuse and which are legs. So first we're going to look at the hypotenuse. It's always the one across from the right angle. So this is the hypotenuse. And the hypotenuse is always going to be C. Then we have our two legs, these two right here that create the right angle. These are the legs. And those are going to be A and B. Mathematically, it doesn't matter which one's which, but A should always, we're going to label A the smaller one and B the medium one. So then we can look at our formula chart and we have the Pythagorean theorem, or the formula that we've been using, A squared plus B squared equals C squared. Number 3, when three squares are joined at their vertices to form a right triangle, the combined area of the two smaller squares is the same as the area of the largest square, which is basically what we're saying here in our Pythagorean theorem. The area of A plus the area of B should equal that largest area, the area of C. So which set of squares does not support this statement? So some of these problems give us our area and some of them we need to find it. So 3 centimeters, that's my side length because it's just centimeters. So to find the area for this one, we're going to do 3 squared, which would be 9. However, for this one, it's already giving me the area. That 25 centimeters squared, that centimeter squared tells me that it's the area already. So this is my area, 25. Here, it's just a side length because it's just centimeters. There's no squared, so I need to square 4, and I end up with an area of 16. So then it asks me, the 3 squares, the combined area of the 2 smaller squares has to be the same as the largest square. So we're going to look at our 2 smaller squares, 9 and 16. Does it equal 25 right here? So 9 plus 16 equals 25. So then yes, it matches here. So this one does support it. So we're looking for the one that does not support this. Then for the next one, the side length is 5. So then for the area, we would do 5 squared. So the area of this one is 25. Here my side length is 13 centimeters. So then I would square that. My area would be 169. For this medium square, it is 12 centimeters long. So then we would do 12 squared to find the area. So A is 144. And then we're going to identify our 2 smallest squares, 25 and 144, and add them up and see if we get 169. So 25 plus 144. So yes, this one does match here. So then this one supports it, and we're looking for the one that does not support it. Now let's do the last one. It should be the answer, but let's double check. So this area is going to be 9 squared, so this would be 81. Right here, it's 9 centimeters squared. This squared right here tells me it's already the area. And then 21 centimeters. We don't have that squared part, so we're going to have to do it ourselves. So 21 squared, you could type that into your calculator. Remember, your squared button is next to the 4, the x squared. And we end up with 441. Then we're going to identify our 2 smallest ones, 81 and 144, and add those up. And I end up with 225. Whoops, this is 441. Let me fix that. So this area was 4041. It does not equal 225. So then set C is the one that doesn't support it. A right triangle is formed by joining 3 squares at the vertices. Find the length of x. So it's asking us to find this length. Okay, so we can use that same formula that we were using up here. The 2 small squares equal the area of the large square. So I already have the area of B right here. Okay, so let's label them A, B, and C. This one is C because it's opposite the right angle. We'll make the smaller one A and the medium one B. And so let's start off with A. The area for A is going to be 8 squared, or 8 times 8, right? Base times height. That would be 64. The area here, I already have the area. One, it tells me A equals, but also it has that squared. Whenever it has that squared, I know that it's the area. So that one's good. And then we're trying to find this area. I don't know what that is yet. So this is my small one, this is my small one. Or if we follow our formula, A squared plus B squared equals C squared. The area for A was 64, or 8 squared was 64, plus the area for B was 225. Should equal that largest area. So 64 plus 225, 982, 289. So this area is 289. So now I know this is 289. But going back to the question, it says find the length of x. It didn't say anything about finding this area. It said find this length of x right here. So I still have one more step. If my area is 289, I can find the side length by doing the square root. So the square root of 289, control x squared in our calculator. Again, the x squared is right next to the 4. So x is equal to 17. And then we're talking about feet and feet, so 17 feet. Let's go ahead and move on to number 5. A rectangle has a width of 3 inches and a diagonal of 6 inches. What is the length? So we're talking about a rectangle here. It has a width of 3 and a length and a diagonal of 6. So a diagonal of 6, we're going to have to draw our diagonal. And it's asking us what is this length? What is this number right here? So this was 6. So because it's a rectangle, I know that these corners right here are 90 degrees because that's what makes a rectangle. So I can actually ignore this piece. And I have a right triangle, which means I can now use my formula A squared plus B squared equals C squared. So I'm going to label them A, B, and C. So this one across here is going to be C, remember, right here will be C. A will be my shorter side, and B will be my missing side, that medium one. And so we're going to find our areas. So we're going to draw some squares to show us that we're looking for our areas. I know they don't look like squares, but they're supposed to be squares. So then this area is going to be 3 squared, which is 9. This area is going to be 6 squared, which is 36. And I can't find this one yet. That's what I'm looking for first. So the area for A, or A squared, was 9, plus I don't have anything for B, right? This was our question mark, so we're going to